Imagine stepping into a booth, pressing a button, and instantly finding yourself on a tropical beach. No packing, no long flights, just pure, instantaneous travel. This is the allure of teleportation, a concept that has captivated our imaginations for decades through the lens of science fiction. From Star Trek to Doctor Who, teleportation has become a staple of our futuristic fantasies. But what if teleportation wasn't just the stuff of science fiction? What if the ability to transport ourselves instantaneously across vast distances was within the realm of scientific possibility? While we may not be beaming ourselves across galaxies just yet, the science behind teleportation is surprisingly real and rapidly advancing. In the real world, scientists are hard at work unraveling the mysteries of quantum mechanics, a branch of physics that governs the behavior of matter at the atomic and subatomic level. And within this strange and counterintuitive realm lies the key to understanding the potential and the challenges of teleportation. Before we dive into the complexities of quantum mechanics, let's first define what we mean by teleportation. In its purest form, teleportation involves the instantaneous transfer of matter from one location to another without physically traversing the space in between. Think of it like sending an email where the information is transmitted instantly rather than physically mailing a letter. However, unlike sending an email, teleporting a physical object, let alone a human being, presents a unique set of challenges. This is where quantum physics enters the picture. In the quantum world, particles like atoms and photons behave in ways that defy our everyday intuition, exhibiting properties like superposition and entanglement. Superposition, for instance, suggests that a particle can exist in multiple states simultaneously until it is observed. Entanglement, on the other hand, describes a bizarre connection between two particles where they become linked in such a way that even when separated by vast distances, they continue to influence each other instantaneously. Imagine two coins flipped simultaneously, one landing on heads and the other on tails. Now imagine these coins being separated by thousands of miles, yet somehow remaining linked. This is the essence of quantum entanglement, a phenomenon Einstein called spooky action at a distance. Entanglement holds the key to transferring information instantaneously between two locations. Picture two entangled particles, A and B. Measure a property of particle A, and it instantly determines the corresponding property of particle B. While the idea of teleporting humans remains firmly in the realm of science fiction, scientists have made remarkable progress in teleporting quantum information using entangled particles. In 1993, an international team of scientists successfully demonstrated quantum teleportation with photons, particles of light. They were able to transfer the properties of one photon to another photon located a short distance away without physically moving the photon itself. Since then, scientists have continued to push the boundaries of teleportation, teleporting information over increasingly longer distances. In 2017, a team of Chinese scientists used a satellite to teleport photons to ground stations located over 745 miles apart, smashing previous distance records. While teleporting photons is a remarkable feat, teleporting larger objects like atoms or molecules presents a far greater challenge. In 2004, scientists at the National Institute of Standards and Technology successfully teleported the quantum state of a beryllium atom to another beryllium atom, marking a significant step towards teleporting more complex matter. Section 5. The Human Puzzle. Challenges in teleporting a person. Teleporting a human being is an entirely different ballgame. The human body is an incredibly complex system made up of trillions of atoms. To teleport a person, we need to create an exact copy of their body, atom by atom, while destroying the original. This raises daunting challenges. Storing the quantum state of every atom in the human body would require more bits of information than there are atoms in the observable universe. Transmitting this data at speeds exceeding the speed of light is impossible according to Einstein's theory of relativity. And even if we could, would the teleported copy truly be the same person as the original? Section 6. The Ethics of Teleportation. A Brave New World. The prospect of human teleportation raises a host of ethical and philosophical dilemmas. If we could create a perfect copy of ourselves, would that copy have the same consciousness, memories, and experiences as the original? Would it be ethical to destroy the original in the process of creating the copy? And what would be the societal implications of instantaneous travel on a global scale? These are questions that science alone cannot answer. As we continue to explore the frontiers of teleportation, we must also grapple with the ethical and societal implications of this potentially transformative technology. It is a conversation that requires the input of scientists, ethicists, philosophers, and the public at large. Section 7. The future of teleportation beyond science fiction. While human teleportation may remain a distant dream, the principles of quantum teleportation have the potential to revolutionize other fields. Quantum cryptography, for instance, promises unbreakable encryption methods by exploiting the principles of entanglement. Quantum computing, meanwhile, harnesses the power of superposition and entanglement to perform calculations that are impossible for even the most powerful classical computers. In the realm of communication, quantum teleportation could lead to the development of instantaneous communication networks, where information is transmitted not through physical wires or waves, but through the entanglement of particles. This could revolutionize fields like telemedicine, allowing for remote surgeries and medical consultations with unprecedented precision and speed. Section 8. Conclusion: a universe of possibilities. The quest to understand and harness the power of teleportation has taken us deep into the strange and wonderful world of quantum mechanics. While the challenges of teleporting a human being remain immense, the principles of quantum teleportation are already transforming our understanding of the universe and opening up new frontiers in communication, computing, and beyond. As we continue to explore the cosmos and unravel its mysteries, we must remember that the universe is full of surprises. What seems like science fiction today may well become the reality of tomorrow. And in the words of the great science fiction writer Arthur C. Clarke, any sufficiently advanced technology is indistinguishable from magic.